Okay, welcome back. So, in the last video, we talked about how to install Zig. Not really too much into the details of how to install Zig because Zig installation differs from operating system to operating system. Uh, there are a couple of issues that might pop up if you are using Windows. Uh, we kind of picked into what might be the reasons, which is due to some of the global variables that might have like a conflict between them. So, and we could not go further into that because not currently running a Windows operating system. So I've used a Mac throughout for this. I'll be using Mac throughout for this tutorial. And then we saw a bit about how to run a simple Hello World application in Zig, how to run Zig init, which is used to initialize a Zig project. And we also saw how to run Zig build, what it means, and each of the files that Zig init creates for us when we start working with Zig. Uh, so, uh, Going forward, we'll be looking into objects. And by object, I mean like there are things like variables, constant. What exactly do that mean in Zig? So, if you are new to Zig, I'll say if you use something like JavaScript before, or you used JavaScript because of some of the keywords will be familiar to you. For example, we'll be talking about the use of var and the use of const, what exactly those keywords mean in Zig. So thereafter we'll look at how to apply a constant uh, variable and also variable object. So let's dive into it. Most Great part of this video will be done in the editor. So we'll need to delete some couple of files from our previous hello world. Or maybe you should create a new file so that we'll see how to do that again in case you don't remember how this is the first time you're actually watching this video. So we'll just make a directory and call it variables. Variables, let's just create that. Sorry, that I think I need to remove that from the word and pull it out into the main folder. All right. So we have that, and then we could just cd into variables. Um, okay, cd out of current folder and cd into variable. Then we can do zig init, which will create our folder, our files and folder we can use for this exercise. So the first thing I want to do is I want to delete some couple of files and do it kind of I will have to do some cleanup. For example, our root file, our root.zip, we won't need it because we are not building a static library or a library at all. So we need something, we need the build.zip. Uh, we are not installing any external dependencies, so we'll just do a couple of things on the build.zip and make everything lean. So we'll erase the comment at least so we can pick into the things that are important and the things that are not important. Okay. So because we are not building a static library, we really don't need this particular static library build. So we can remove that and also remove it as an active act. Then we could leave the executable because we will be running just the binary objects. And so we'll leave that. So we have binary dot install, then we could we'll leave the run command. And since the run command is also dependent on the build install, we can still leave that. And we're not passing any extra argument as of now, so we don't really need this, but we could still leave it just in case during the course of the exercise we decide to put and decide to pass an argument into it. So we have the run command. So we don't need the unit test from the library. We don't need it, and we don't need it for this also. So now we just have exactly what we need to run for this whole project, this whole folder. Okay, so we did the root file, so we don't need that. So if we do zigw there, kind of, so okay, so if you do zigw here, we are going to get our zig out with no errors. So we have exactly what we need. This is just our basic binary. We don't need more than that as of now. So let's take a quick look into what we're doing today. Uh, in this video, we will strip out more of this because we don't really need to know how to print to the standard output as of now. We will just want to focus on variables and also like introducing ourselves to arrays and the primitive data types in Zig. So we could delete every one of this, and then our test. We don't need the test. If we do need the test, since we don't need test, we could come up down over here and strip out the test step for even this. So since we won't be using the test. Probably let's just leave the test so we could do some basic testing for that. Um, so now we have exactly what we need as a bare bone project. So constant and variable objects in Zig are quite like things coming from other programming language. Really things you probably have experienced like immutability and mutability. You might have experienced them. So for const is always it means constant. That is, it's not mutable. That is the keyword specified that you can mutate something. For variable, it means that you can mutate it. So if you use a const, then the object you are creating is immutable. That's the intuition behind it. Uh, so when you declare such object, you can no longer change it once you declare it. On the other side, you have if you use a var keyword, you can make it as much as you want. It's similar to the let mute in Rust in case you've interacted with Rust a bit. Uh, but if for the const part, it's just the let keyword in Rust. And if you've not tackled Rust, just think of it as something that is fixed, can be changed, and something that can be changed. So going further, let's create a let's create a simple a constant and see what we mean by it can be changed. By the way, we have types in Zig that we'll talk about in a bit. And if you in the previous video, I mentioned that Zig can infer data types. So that's one cool thing. They can infer data types. So if you have 45 here, you can see that there's a no, so there's a compile time integer here, which means that at compile time this can be inferred, and the Z compiler knows exactly the data type of variable, this particular constant variable. And the reason for it being compile time is during compilation, since the 45 um, can be stored in a static space. I don't really want to dive much into that, but if you down into the OS mode, when you compile when you try to run a program, there's a static space, there's a data space, there's a heap, and there's also stack allocation. So this can be built into the binary. Then you have age. Age If you try to change it to 56 now, then we'll get an error here. Although it doesn't show it directly. But if we do run our if we do build, we'll get an error. And let me put it up very properly so you see. So at line five, you cannot assign to a constant, and that's because constants are immutable rather. So in contrast, if we decide and we change this to a var, that is a var keyword, this is no longer this can change. But so if you build it, we'll see an error here. And the reason we decide is that it's a compile time integer. For us to do this, we have to we have to tell our compiler that it is that we don't know the type, the size at compile time. So for example, you have to use a usize to do exactly this without getting an error. So you can see we don't have an error. And the reason being that there's a difference between variables at compile or during compilation. Once you have a variable with a value that can be that the compiler can assert the size of that value at compilation, you have a compile time integer. Say for example, the compiler is running through your code and can see that you have a value of 1. It knows exactly the size of 1, so that's a compile time integer. But say for example, the size of that integer can change in something like a loop, for example. You are looping from 1 to 1000, it can change, so that is not a compile time integer. So going further, there's a SIG is able to like detect which value of the object is compile time and also which value of the object is not compile time. And if you want to perhaps specify that you want the compiler to perform an operation at compile time, they also Zig also allows you to do that. So we'll see that later on as we continue. So another thing now is okay, declaring without initial value. So declaring without initial value, yeah, I'm quite sure if you've actually used something like JavaScript before, you might have seen this keyword called undefined. It comes with a bit of trick in JavaScript, but it's pretty much cool. Every language has its own specification and design and the reasons for it. So Zig also adapted the use of the undefined keyword. For example, you don't know the value of something when you actually created the variable. You could use undefined. So by default, when you declare a new object in Zig, you must give an initial value. That's the default. But in some cases, perhaps you might not have that value out, like on the top of your head, you could not put the value out. You can just give it an undefined, like as a value. You can set it to undefined. For example, we don't know the size of this. We can give it undefined here. Then we can later on set it. But the important thing to emphasize is that you should always avoid undefined as much as possible because it can trip you off at any point because undefined means that you don't have a value for it, it's uninitialized. And if you use the value while it is uninitialized, you can get an undefined behavior, which is similar to what you actually get in a language like JavaScript too. So you should be very careful when using undefined. Probably from my recent use of Zig, I tend to use undefined when I don't know the value at that point. But maybe 2 lines or 3 lines after, I tend to know what the value might be, and I know that it's going to give me I'll resolve it into a value. Another thing to mention is that there are checks that you could use to like to check if something was undefined. So I think with that, undefined is it's something you figure out when to use and when not to use it. So it's a very it's a cool keyword. in Zig too. Like it's not a keyword per se, but it's a value. It's also a keyword because it probably can use. It's not a keyword, so it's not a keyword. So there are also there's no such a thing as unused value in Zig. That's a classic thing that you will see every time because if you declare a value and you don't use it, you are not going to be able to you won't be able to compile it because you must always give the value and it's quite like if you create a function and there are values in it and you don't use it, you have to either assign it to an underscore or you have to use it. If you don't use it, the compiler is going to scream at you. So therefore, that's the meaning of there's no such thing as unused object in Zig. So you must always use it. Like once you create it, you have to use it. So it's kind of like preventing you from having dead code. So Zig is quite strict about that. So it doesn't matter the way you use it. It really doesn't matter like if you try to, as long as you make use of it, yeah, the compiler won't scream at you. So like a classic example of that would be if I just comment out this line and you can see we have an unused local variable. And if I decide to build, I won't be able to do that because it still screams at me that I did not use the local variable that I created. So, but in that case, if I say, okay, fine, I have this and I want it to be underscore age, I have to make it const. And the reason for making it const is that since at compile time it is an unused constant, the compiler is not going to complain that you are not using a constant, but it's going to complain that you are not using a variable. So this will work without any issue. So every time you declare an object in Zig, there are two choices that you need to do. It's either you use the value of the object or you discard the value of the object. And from recent programming languages like Golang, Rust, Zig also allows you to use underscore to have to like discard variables like the values of the object that you're using. So um, to print something out to the to like the console or to the command to the standard output, you can just use something very cool in Zig that is called debug, std debug. It's not like the debug, and you can just print to it. And it's pretty easy to print in Zig. All you have to do is follow the format. There are formatting uh, conventions that Zig gives you so that you can like print to the standard output or standard error, depends on what you're working on. So an example is if you are printing, let's see, for example, we are printing an integer, we could use the value, we use the the format specifier like D. But then there's this there's this way of passing arguments to it. You have to use the curly braces here to specify a list of arguments that you are passing to it. Later on, we'll see what that means when we get to the array section, so you understand better what uh what exactly the syntax means. It's quite tricky, but after a while you get used to it. So if you just pass the aging to this place, and then we have if you build sorry, it's assigned to a constant. Okay, yeah. If you build it, we get then you can do zig run. It shows the zig run, zig build run. So So you can see why we have 45. Not sure if you can see it now. So we have a 45 here. So another key thing to mention is that you must mutate every variable object. So every variable object that you create in your source code must be mutated at some point, else you're going to get a complaint from the compiler. And that's why it means that if you do not mutate them, you have to use the const keyword, which makes it like a constant variable, and it means you are not going to be modifying that variable to be baked into the binary. So that's exactly why you need to mutate every variable object. Apart from that, if you if you would not like to mutate any variable object, that means you have to use the underscore to do that. And for you, so another thing is that okay, if you try to like mutate a variable and you have like you use the underscore, you can because you never actually mutated the variable, it is going to complain. You have to still use a constant. An example is using a similar example such as this, where you have a string. If you look carefully here, you see that we have like a where I live variable, but it was not mutated. So and it was assigned to an underscore. Ideally, this should be correct, but because you did not mutate it, and the rule says that in Zig, every variable object must be mutated. So therefore, you have to mutate it, or else you have to assign it to a constant variable. So once you assign it, this works. And if you do not do that, you have to say, okay, right over here, you have to say, okay, I am using this. Probably you are giving it to, you're adding something to it, or you are not. But this, it's not, you could do something like answer equals this plus, and then we could say, let's print debug answer is since we are not still mutating it, we are only assigning it to another person. We have to use a constant. And if you the the idea is that once you use a variable and you're not mutating it, it doesn't like the actual answer is not changing. The actual where I live variable is not changing. Then you have to use it as a constant rather. So we could run this. So you could run so you get the value plus 45 at the back because we added 45 to it. So one thing to note is that if you look closely, we used plus plus, it's in an operator for string concatenation in Zig. So going further, we'll look more into that. But for now, that's all for this video. In the next video, we'll be taking a look at primitive data types, and then going further into arrays and block scope, so we understand more about what Zig has to offer in those areas. Thank you for joining the session.